Welcome to 8.3, video 2 of 2 for IM1. The topic here is the midpoint and distance formulas. This is a really important concept, so make sure you're taking really good notes on this one and following along with me. So let's begin by talking about the midpoint formula. All right, in the last lesson, we talked about the idea of midpoint. In this lesson, we're going to actually come up with a formula that gives us a way to figure out where the midpoint is. So just experientially, right, if I have this line segment here from A to B, then the midpoint is going to be somewhere over here, right? I mean, if I was going to cut this in half and fold this segment on top of each other, then I'm saying the midpoint has to be somewhere right in this region. So how do we get it? So let's begin by first taking a look at sort of like the x-axis, okay, for now. So if I were to sort of trace this point down to where it is on the x-axis, and then trace this point down to where this is on the x-axis, I would be covering this distance, right? So this would be 8, and this would be 2. So what's the halfway point between 8 and 2? Well, the halfway point is clearly 5, okay? So how could we like maybe think about doing that? So I'm gonna draw a vertical line at the halfway point for my x-axis. So let's write all this down. So the halfway point, right? The halfway point between what I have of 8 and 5 would just simply be the absolute value of 8 minus the 2, and then, if I take, not 8 minus 2, excuse me. The halfway point, how do we come up with 5? Would be, take the total distance that I had, the first one, which is 8, so from here to here. So take 8, and then I did another distance of 2, and add 2, and then split that in half. Take the average of those two. So therefore, that's 10 divided by 2, so therefore it looks like 5, all right? So 5 is the halfway point between 8 and 2. So there's sort of the math behind how I did that, okay? Now let's change it up and let's do the y-axis. Okay, so let's look in this direction. So if I take point B and I go look back to the y-axis, that would be 6. Take point A, go back to the y-axis, that would be 1. And again, ask yourself the same question, right? What's halfway between 1 and 6? And you would end up with, the point being 3.5. So it would be somewhere here. So I'm going to draw the line here, right there, and draw a horizontal line where it extends out. So how do I get 3.5? Well, I take my first distance of 6, my second distance of 1, and then divide it by 2. So 7 over 2 gives me 3.5, right? So 3.5 is the location where I'm halfway between 1 and 6. So what do you notice? You should be noticing that these points are meeting at a certain location, and that location is 5, 3.5. So this location right here is 5, 3.5, and that is how we find the midpoint of any 2 points. So let's take a look at what we did, right? How did we come up with the 5? We came up with the 5 by adding our x's together, so x1 plus x2, and then taking the average of those. And then how did we come up with the 3.5? Well, we took our y's, y1 plus y2, and we took the average of those. So what I mean by x1 and x2, right? Point A is located at the point 2, 1. Point B is located at the point 8, 6. So if I take the average of the x's, so an 8 and a 2, which is what we did over here, that gives me the 5. Similarly with the y's, the 3 or the 6 and the 1 gives me 3.5 when I take that average. So that's our formula right down here. This is our formula for how we come up with the midpoint. And it's a really important to remember that midpoint means location. Okay, so when I'm asking you for a midpoint, I'm asking you for a location, which means you have to give me an x, and then you have to give me a y. All right, so an x and a y. That's everything you need for box number 1. Okay, box number 2 says using the midpoint formula, so I'll change colors here. Using the midpoint formula, so the endpoints of line segment RS are located at R, which is at 1, -3. So let's put that on the graph, 1, -3. 1, -3 is that be here. So that is point R. And S is at 4, 2. So 1, 2, 3, 4, 1, 2. This is point S over here. And there is a segment that joins them, that goes between them, okay? And it says, find the coordinates of the midpoint. Well, again, right, let's write these down. R is located at 1 comma negative 3. S is located at 4 comma 2, okay? So our midpoint formula, and I'll do this for you over here, okay? Our midpoint, the way we figure it out is going to be, we're going to take the average of our x's, so x1 plus x2, and then divide by 2, and then take the average of our y's and divide by 2. So our midpoint is going to be, okay, location, so x1 is be this guy, so 1. x2 is this guy, 4, so 1 plus 4 divided by 2. The y's is this guy, so negative 3, plus this y, which is 2, and then divided by 2. So let's see here, 4 plus 1 is 5, 5 divided by 2 is 2.5. Negative 3 plus 2 is negative 1. Negative 1 divided by 2 is negative 0.5. So there is our midpoint. So 2.5. So I would go 1, 2.5, and then down a half, and that seems to be exactly where the midpoint should be, right about there. And again, right, if I were to draw a line back and draw a line back to the y's, cut it in half, then that's where they would cut in half. And similarly, if I were to draw back to the x-axis and cut that in half, then they would clearly meet right there in the midpoint, labeled M, so that would be our midpoint. And that's everything for box 2. Okay, box 3, the distance formula, another super important idea in this particular section. Before we begin the distance formula, you have to remember the Pythagorean Theorem. Now, if you don't remember the Pythagorean Theorem, I put a little purple and gray box or cloud over here for you to remember it. So here's a little recall. The Pythagorean Theorem is all about the distance and the relationship and the sides of a triangle as long as that triangle is a right triangle. So we have, if we call this leg A, and we call this leg B, and we call the side that is opposite the hypotenuse, side C, then this relationship is true. A squared plus b squared is equal to c squared. So hopefully this rings a bell to you. If not, I put it on the lesson so that you would remind yourself of what to do. Okay, so let's develop the distance formula with an example, and then we'll do it in general. And I'm going to use the exact same picture as before, all right? So I'm going to go ahead and label these points here. This is point A, and point A is located at the point 2, 1, and B is located at the point 8, 6. So again, I'm going to draw my lines back to my x-axis coordinate. And what I'm going to do is I'm going to get this distance, right? So this distance from here to here is a distance of 1, 2, 3, 4, 5, 6. So this is a distance of 6, okay? I'm going to do this exact same thing with the y's. I'm going to draw a line back and draw a line back and figure out this distance here. Well, this is 1, 2, 3, 4, 5. This distance would be 5. Now what I can do is I can draw a right triangle on the page, and that where I would do that would be right here. So check it out. I could draw this side and this side, and I could make a right triangle right on the page. And I would see that this distance is still 6, this distance is still 5, and this side, the hypotenuse, this is what I'm interested in. This is the distance between A and B. So we can use the Pythagorean theorem. We know that A squared plus B squared is equal to C squared. Remember, the 6 is acting like my A, the 5 is acting like my B. So 6 squared plus 5 squared is equal to C squared. C is equal to the distance. Remember, C is the distance I'm looking for between A and B. All right, well, I can keep going with this. This is no big deal. 6 squared is 36. 5 squared is 25, and that's equal to C squared. So 36 and 25 is a grand total of 61 is equal to C squared. So therefore, C is just going to be the square root of 61. And again, if you don't know that, that's okay. You don't have to. You can just plug these in into your calculator. So as you can see on mine, if I did, 36 plus my 25, that's where my 61 comes from. And then on the calculator, I can take second square root, second answer, and then get a value of approximately 7.81. Okay, that's good enough. So this is going to be So C is going to be the square root of 61, which is approximately 7.81. Okay, so what did we do there? Let's talk about this in general, right? So over here, in general now, so what did we do? Okay, well, the distance, right, the distance that I'm looking for is just going to be the square root of 6 squared plus 5 squared. Well, how did we get 6 squared? Well, remember, we just took this value minus that value. So that's going to be x2 minus x1, and then we're squaring it. And then how do we get 5 squared? Well, that's just this value minus that value. So that's going to be y2 minus y1 n squared. And that is going to be our distance formula right there in orange. So super important that you write that one down. x2 minus x1 squared plus a y2 minus y1 quantity all squared. That will give us our general distance for any 2 points that are on the plane. Okay, last example here of the lesson is box number 4, using the distance formula. It says that your school is 4 miles east and 1 mile south of your apartment. A recycling center where your class is going on a field trip is 2 miles east and 3 miles north of your apartment. Question is, estimate the distance between the recycling center and your school. Okay, so first things first, you have to know north, south, east, west. So I drew you a little map over here. North is up, south is down, east is right, west is left. So let's go ahead and put your apartment somewhere on the map. So your apartment is here. Okay, cool. There's our apartment. Ding, no problem. The recycling center, your school is 4 miles east and 1 mile south. So if I do 4 miles east, so I'm going to do this. I'm going to do 1, 2, 3, 4. That's 4 miles east. And then 1 mile south would be this one. So each square is going to represent 1 in my case. So 1, 2, 3, 4, 1. So this is where our school is. That's where our school is, okay? And then it says you're going on a field trip and the recycling center is 2 miles east and 3 miles north, okay, from your apartment. So 2 miles east would be that way and 3 miles north would be this way over here. So my location is going to be up there for that one. Okay, so 2 miles east, 1, 2, and 3 miles north. So here is the recycling center. All right, and the question is, estimate the distance between the recycling center and your school. Okay, so what they really want us to know is what is this distance right here? Let's estimate that, okay? So I'm gonna do this for you 2 ways. The first way is just knowing and what I know about right triangles and looking at it. So if I were to make a right triangle from this, I would see, well, like this would be the right triangle that I would make, and the distance here is the thing that I'm looking for. So this distance is 2 miles, and then this distance is 1, 2, 3, 4 miles. So if I just know that, then I can say that the distance is going to be the square root of 2 squared plus 4 squared. So my distance is going to be the square root of 4 plus 16. So my distance is the square root of 20, which is approximately, if you don't know that, that's okay. You can bring in your calculator and do second square root of 20 and get about 4.47 miles, okay? 4.47, and this is in miles. Okay, that's the first way. That's probably the way that I would do it. Now, if you want to do it the more traditional way in terms of like how you would do this with a coordinate, here's the other way that I would consider thinking about this. Okay, I'll do it in a purple color for you. If we consider this point to be 0, 0, if your apartment is 0, 0, then this point over here is going to be 4, comma, negative 1. And this point over here would be 2, 2, comma, 3. Right, so that would be the other point there. So the distance then would be the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Well, what's the value of x2? That would be this guy up here. So this is going to be the square root of 2 minus 4 squared plus 3 minus negative 1 squared. That's going to be the square root of -2 squared plus 4 squared. And you can see we're going to end up right back where we were before. So this is going to be a 4 and then a 16. And that brings you right back to where we were before. And you can just continue on from there. So there's the more sort of traditional approach. But if I was given this problem, I would just make the right triangle on the graph and do it the first way that I showed you. All right, that covers everything for the last video. Please let me know if you have any questions whatsoever.